Section 4.2, Grandmaster, critical thinking problems. Number 1, it says simplify each expression and state the answer twice. First, using positive exponents, and number 2, evaluated. Evaluated just means to be worked out. So the first one, 3 to the negative 4 divided by 3 to the negative 2. These bases are the same, so I can subtract the exponents. So this is negative 4 minus negative 2. So negative 4 minus negative 2, that's negative 4 plus 2, so it's negative 2. And then this can be written as 1 over 3 to the positive 2. So that's the first answer it wanted. Okay, we want positive exponents, but then we want it evaluated. So just work out what the number is. So that's 1/9. Okay. Positive exponents evaluated. 8 to the power of negative 1 divided by 8 to the power of 0, all cubed. Well, 8 to the power of 0, that's just 1. And anything divided by 1, that's just itself. So this is just 8 to the negative 1 cubed. All right. So my double exponent. So I'm going to multiply them now. So this is going to give me 8 to the power of negative 3. So I can rewrite that using positive exponents only, like so. There's our first answer. And then to evaluate it, I just have to work out what 8 cubed is. And that was one of the ones I suggested that you memorize, perfect cubed. So we get 1 over 512. The third one, 4 times, in brackets, 2 to the negative 2 times 2 to the minus 1, and that's all being raised to the negative 1. Whoa. Yuck. Well, I can see a whole bunch of different options available to me. I'm going to work at the inside. So I'm multiplying two powers of the same base, so I get to add the exponents. So this is 2 to the minus 2 plus negative 1. And that's still raised to the minus 1. So I'm just working on the inside right now. Okay, so this is 2 to the power of minus 3. Okay. Now, the 4 is outside this set of brackets, so this minus 1 here has no effect on it. So I'm going to multiply these exponents together. So this is going to give me 4 times 2 to the power of positive 3. Okay. So there I have it worked out, and I only have positive exponents. But now to evaluate it, 2 cubed is 8 times 4 is 32. Number 2, simplify each expression by restating it using positive exponents only. Okay, so I have a whole bunch of brackets here. X to the 6 times x to the minus 3. Okay, multiplying powers, same base, I can add the exponents. Okay, so 6 plus negative 3 is 3. So that's going to give me x cubed. And that's being raised to the minus 1. And then this is being raised to the minus 2. Okay, so all I did was work out this. Okay, so here I have a power being raised again. Let's just multiply them. 3 times negative 1, of course, is negative 3, times 2 is 6. I think that's about all we can do. Next, in brackets I have xy to the negative 2, okay, but this negative 2 is only affecting the y, it has no effect on the x. but everything inside this set of brackets is being affected by this minus 1, and then that still is being affected by this minus 5. Okay, so again, you have multiple options here. I can get rid of some of these negatives because I know those double exponents, I can just multiply those. Okay, so this is going to give me xy to the minus 2. So I haven't touched that inside yet, but this will become positive 5 because negative 1 times negative 5 is positive 5. Still over x to the 4th. Now, everything in here is being raised to the power of 5. The x and the y to the negative 2. So this becomes x to the 5th, and then this becomes y to the negative 10 over x to the 4th. Okay. Well, we can simplify. I have x to the 5th divided by x to the 4th. Okay, the bases are the same, so I get to subtract the exponents. Well, that's just going to give me x to the 1, or just x. And I have a y to the minus 10 in the numerator, so I can put that in the denominator and make it y to the positive 10. Okay, so this was pretty gross looking, and you can see that our simplified answer looks a lot simpler. Question 3. Radium is an element that decays over time, means it's not stable. The most stable isotope, called radium-226, has a half-life of 1600 years. If a sample compound contains 600 atoms of radium, the radium will decay over time according to the equation n equals 600 times 2 to the power of negative t over 1600. Oh, that's a mouthful. Where t is time in years. Question part A, how many atoms remain after 3200 years? Okay, well, first of all, if you don't know what half-life means, it just means how many years does it take for half of the amount to, well, in this case, decay, to disappear. So, how many atoms remain after 3200 years? There are two ways of answering that question. One, we can just use common sense, and the other, we can actually do a little bit of math. We know that the half-life is 1600 years. So if we have 1600 atoms in the beginning, 1600 years later, I will have half that remaining. So there will be 300. Okay? Another 1600 years after that, well, that 300 will be cut in half again. So that would be 150. Okay? Well, it so happens that 3200 years is actually double the half-life of 1600. Okay, so you can think of 3200 years as 2 half-lives. So it's like you're cutting 600 in half twice. Right? So you have 600, okay, and after 1600 years, you would have half of that left. And then in another 1600 years, you'll have half that again. Okay? Now that was easy to do because the numbers happened to work out fairly well. But if the numbers were ugly, we would actually refer to this equation here. So I'm going to use that now. So I'm going to use the equation n, which is the number of atoms, equals 600 times 2 to the power of negative t. Well, t is 3200, so this is negative 3200 over 1600. So I'm just working out n. Well, negative 3200 divided by 1600, that's just negative 2. Okay. Well, 2 to the power of negative 2, remember that negative 2 has no effect on the 600. That can be thought of as invisible 1 over 2 to the power of 2. And 2 to the 2 is just 4. So that gives you 150. Part B. What does t equals 0 represent? Well, t is in years, so 0 years, well, that just means no time has gone by. Okay, so no time has passed since, I should have left myself more room, there were 600 atoms. So we're just at the beginning. So no time has gone by. Part C, what do negative values of t represent? Well, when t equals 0, that's when we kind of start the clock. Okay, we have to start it somewhere. So if a value of time is negative with respect to when we started, that just means we're talking about a time before. So negative values of t refer to times before there were 600 atoms. So for example, what if t was minus 1600 years? So this was 1600 years before we started the analysis. Well, that 1600 years refers to the half-life, but if it's before, we would have double the amount. So 1600 years before there were 600 atoms, that means we would have had 1200 atoms. Okay? And then another 1600 years before that, in theory, we would have 2400 atoms. So every time time goes backwards, the amount of radon we have would double. And every time time goes forward by 1600 years, we cut the amount we have in half. Hence, half-life. And here is an illustration of that. So this is when time equals 0. This is when time equals 1600. This is when time was negative 1600.